Welcome to today's lesson. I'm Siamasaki Kendens, and so I'm going to take you through a lesson in physics. So we go to the lesson straight away. Actually, today we're looking at kinetic energy and potential energy. And so we go straight into looking at kinetic energy. Kinetic energy is actually the energy a board has because of its motion, meaning that a board should be moving for it to have actually kinetic energy. And this is a very, very, very important that a body should be moving for it to have actually so the body, which is the key word here, is actually the body should be moving. And the units for actually kinetic energy are the joules, and for mass they are actually the kilograms, and for velocity they are meters per second. So kinetic energy is equal to half multiplied by mass multiplied by velocity squared. So this is key, and this is actually the definition of what kinetic energy is. And so we were saying kinetic energy is equal to half multiplied by the mass multiplied by velocity squared. And we said actually the mass would always be in kilograms, while the velocity should be in meters per second. And then kinetic energy should be in joules. Okay, so this is very, very important. And so what about potential energy? Potential energy is actually the energy that a board has because of its position or condition. In other words, the board has to be elevated to some position with respect to a reference point. So there will be a reference point. For example, if the reference point is actually the Earth, so we are saying from the Earth, how far up has it gone? And so here, the key point actually is that a body with potential energy will be affected by the gravitational field strength. And so the gravitational potential energy is actually a gravitational potential energy. And so here there is actually G. Gravitational potential energy is equal to actually mass multiplied by gravitational field strength multiplied by height. And the mass, as usual, will be in kilograms, while the gravitational field strength will be actually, as it is shown here, it will be in newtons per kg. And then the height will be actually in meters. So what we are saying here is that potential energy is actually, this is gravitational potential energy, is actually equal to mass multiplied by gravitational field strength multiplied by height. And the mass here will be in kilograms, and the gravitational field strength will be in newtons per kg, while the height will be in meters. And then the gravitational potential energy will be as well in joules. As simple as that. So this is a very important illustration, and you actually very important illustration to actually to know that actually potential energy is equal to mass multiplied by gravitational field strength multiplied by height. And so when a body is actually has moved a height, this height there, it means that where it is here, it's going to have the highest potential energy. when it's elevated through a height h. And before it starts moving, coming down, momentarily when it's at rest, before you release it, it's going to have zero kinetic energy, because we said kinetic energy is as a result of the movement of the object. And when the object actually is halfway, it is going to have the same amount of potential energy and kinetic energy. And as the body goes down and it reaches actually the lowest point here, it hits the ground, it means that the height would have reduced to zero, and therefore the potential energy would be zero, while the kinetic energy, just before it hits the ground, to have the maximum speed. So all the potential energy the body had up here to have been converted into kinetic energy. So it will be actually all converted into kinetic energy. Another illustration we can give for conversion of energy is on the pendulum. Pendulum is made of actually a string which is attached to some point, and on the other side it has a bulb. The bulb is actually a mass. And so if you actually pull some point, this bulb, for example here, it means that from the resting position it would have gone a height h. And therefore, if we are to calculate the potential energy for this bulb, it means that its mass multiplied by gravitational field strength multiplied by the height, this height here. While at that point, if it's not moving, before you release it, actually, it will have zero kinetic energy, because kinetic energy has to do with movement. When you release the bulb actually, midway before it reaches this point here, it will have a similar amount of energy with that of potential energy and kinetic energy. When it reaches down here, it will have the highest speed as it is going up there, and therefore it will have maximum kinetic energy. All the potential energy here will have been converted into kinetic energy. For example, if the potential energy here was 12 joules, it means that the kinetic energy at this lowest point here will similarly be 12 joules, while the potential energy at this point here will be actually zero, because the height would have diminished or reduced to zero, and therefore the potential energy will be zero. Similarly, as the ball goes up here, in between here, it will have the same potential energy, value of the potential energy as that of the kinetic energy. And when it goes up there, the highest point here, because of this height from the resting position, to have maximum potential energy. And just before it comes back, momentarily when it will be at rest, it will have zero kinetic energy. And so here we have seen how actual energy is converted from one form to another, and no energy actually is lost. And so that's why we are saying conversion of energy. So energy can be converted from one form to another without actually destroying it. So this is actually the illustration here. And so now we go straight into illustrate more actually to some questions we can solve in potential energy as well as kinetic energy. The first part of the question will be very simplified, and we'll look at actually how we can calculate kinetic energy, given that we have a car with a mass of 3,000 kilograms and a speed of 20 actually meters per second. So we can now calculate the kinetic energy. As we said, kinetic energy is equal to half multiplied by the mass multiplied by velocity squared. Therefore, we are saying the mass is actually 3,000 kgs multiplied by the velocity, which we said it is 20 meters per second. So 20 times 20 since it's squared. And actually, this gives us 600,000 joules. So this is now our kinetic energy. So this is as simple as that. So here illustrated actually that we can easily merely plug in the values which are given 3,000 kgs where there is mass, and the velocity which is 20, just square it, and we find the value of the kinetic energy. The second part of the question is asking us actually to calculate the potential energy of a 4 kg mass, which is raised to a height of 20 meters above the ground. And we assume that actually this ground is on Earth. And so the gravitational field strength we're going to use here is that of the Earth. So we can now calculate the potential energy is equal to mgh, which is actually we have said that the mass is 4 kg. So 4 kg multiplied by the gravitational field strength on Earth is actually 9.8 newtons per kg, then multiplied by the height, which we said this is 20 meters. And so we find that actually our potential energy is equal to actually 784 joules. So this is a simplified version of how we can actually calculate the kinetic energy as well as the potential energy of a body. We have merely substituted the values which are given. And so we go ahead and again look at another question. But this question now is a bit complex, but it requires us just to think and define what potential energy is. A book with a mass of 3,000 grams is raised to the top of an inclined plane as shown. Calculate the potential energy of the book when it is at the top of the wedge. And so we are saying here, actually we have a book here which is raised up, which moves up to that point through a distance of 5 meters. And again, the other point here is that actually down here, this distance, this side here is actually 4 meters. And so it's raised. So they're asking us to say, what would be the potential energy when it is at that point there? And so for us to be able to calculate that point, the potential energy, it means that we need to find this height. And for us to find the height, we can actually, since this is a right angle triangle, we can use Pythagoras Theorem. And so we can say actually we can say actually phi squared would be equal to 4 squared plus height squared. This gives us 25 is equal to 16 plus height squared. This gives us actually 25 minus 16 when we bring the 16 this side, which is equal to height squared. So we have 9 here. 25 minus 16 is 9, which is equal to height squared. So height is equal to the square root of actually 9, which is equal to 3 meters. So we have found actually the meters. We have found the meters for actually this height here. And so now we can calculate the potential energy. So the potential energy would be equal to mgh. And here we had actually our mass to be 3,000 grams. When converted to kilograms, it gives us actually 3 kgs multiplied by gravitational field strength for the Earth, which is actually 9.8 newtons per kg, then multiplied by the height, which is actually 3 meters. And so it gives us 88.2. It gives us, when you calculate that one, it gives us 8.2 joules. And so this is the potential energy the object or this book is going to have at that point here, the height, this point there. That is the potential energy it's going to have. Next, we look at another question. This question actually involves conversion of actually energy on a pendulum. So a pendulum bulb of mass 2 kg swings from point A to point B as shown below. So we have a pendulum which swings from point A to point B. Calculate the gravitational potential energy of the bulb at point A and point B. So it is a 2 kg bulb. And so we have to calculate the potential energy at point A and point B. And so the potential energy is equal to mgh at point A. So we want to find that point A. What is the height at point A? It is 0.5 meters. And so we have the mass. We have been given that the mass is actually 2 kg. So we will say 2 kg multiplied by 9.8 newtons per kg multiplied by the height, which is 0.5 meters. And so the potential energy at point A, actually it is 9.8 joules. So what will be the potential energy at of this bulb at point B? So at point B, we note that all the height would have diminished, would have reduced to 0. And therefore, if we are to calculate the potential energy at that point, it will give us 2 kg multiplied by 9.8 Newton per kg multiplied by height, which has reduced to 0. And therefore, our potential energy will be 0 joules. That is at point A, at point B, and that is at point B. And so now we look at the second part of the question, calculate the kinetic energy of the bulb at point A and at point B. So we need to find out what the kinetic energy is at point A and point B. So at point A, just before the bulb is released, it's not moving, and therefore its potential energy is actually maximum, while its kinetic energy is 0. Okay? And so the potential energy, so we are calculating now, okay, the kinetic energy. The kinetic energy at point A, actually, it will be 0. So, kinetic energy will be equal to half mv squared at A. At A, actually, because this object is not moving, the mass, as we indicated, it is actually 2 grams. So 2 grams multiplied by 0 squared. And therefore, actually, the kinetic energy at that point is 0. Okay? Now we calculate the kinetic energy at point B, which will be actually mass times v squared at B. And so we note that actually at B, all the kinetic energy that is there is actually gotten from potential energy. So all the potential energy would have actually changed into kinetic energy. And therefore, it will be the same, which is 9.8 joules. So that is the potential energy, or the potential energy, which was at this point here, it would have all changed into kinetic energy. While here, the potential energy would be actually 0. But all the kinetic energy would have actually been changed from there, because here it would have the maximum speed. And therefore, now the last part of the question is asking us to calculate the velocity of the bulb at point B. Now that all the energy, all the potential has been changed into kinetic energy, what would be the velocity? And so we can say now kinetic energy is equal to half mv squared, which is equal to 9.8 joules, because all of it has been changed. All the potential energy has been changed into kinetic energy, and therefore we merely substitute here half multiplied by 2 multiplied by v squared is equal to 9.8. That one and that one will cancel. Therefore, our v will be 3.1 meters per second. And so we have actually demonstrated here, or we have delivered the message that actually we can calculate the kinetic energy as well as the potential energy, and that actually energy can be converted from one form to another. And so today we have looked at how we can calculate the potential energy and kinetic energy. So I hope you can subscribe to my YouTube so that you can get more of these lessons. I thank you.